Alright, sections 5.2 and 5.3. We're going to talk about some functions. And we have a definition. A relation is a set of ordered pairs. The domain of a relation is the set of all the values of the independent variable. Remember, that's usually x. And the range is a set of all the values of the dependent variable. And then a function is a special kind of relation. A function is a relation in which each input leads to exactly one output. And then it asks for the relations, which are functions. Well, remember our rule for function is each input has exactly one output. So looking at relation number 1, I see that the input 3, the independent variable 3, has two different outputs. That's not allowed. So relation 1 is not a function because x equals 3 repeats. Not allowed. To be a function, the x values cannot repeat. The y values can repeat. That's fine. The y values can repeat as much as you want, but not the x values. Relation 2, is it a function? Well, I look. Each of the x values are different. So yes, that is a function. It really doesn't matter at all what the y values are. The y values could be the same. It could be 27, 27, 21, 21, 15, but it's not. The y values are all different too. That's okay. But really, the only important thing is that all the x values are different. So this one would be yes. You're going to look at number 3 and number 4 and decide if those are functions. Now it says for the function, so for relation 2, determine the domain and range. Well, again, the domain is the set of all values of the independent variable. That's x. So for number 2, the domain, we would say the domain is 3, 4, 5, 6, and 7. And typically they would be put inside fancy brackets like that. Conversely, the range is all of the y values. So the y values, I'm going to write them in order. I suppose we don't have to, but I'm going to just because that's habit. 15, 18, 21, 24, and 27. Alright, so sometimes we look at functions in terms of tables and in terms of ordered pairs. Sometimes we look at functions in terms of graphs. And if you have a graph, there's a very simple test to tell you whether or not that graph is a function. And that test is called the vertical line test. The vertical line test says a relation is a function if and only if each vertical line intersects the graph of the relation at no more than one point. Alright, so here are some graphs of some relations. And it asks, which of these relations are functions? Well, think about drawing vertical lines. This first one, part A, if I were to draw a vertical line, let's say I drew that vertical line, it only hits once. So that's good. Or if I were to draw a different vertical line, it hits the graph once. This vertical line only hits the graph once. No matter where I go ahead and I draw a vertical line, that vertical line is only going to hit that graph one time. So the answer to part A would be yes. It is a function. Part B, however, I think we'll very quickly decide is not a function. For example, if I were to draw this vertical line, we would see that that hits the graph more than once. Now, why does that work? Why does that make it not a function? Well, here's what's happening. Look at these 2 points right here. It looks like I have the point, a little hard to read here, the numbering's a little small, but this one looks like it's 1, 2, and this one here looks like it's negative 1, is 1, negative 2. So why is this not a function? Because x equals 1, one of the independent variables, is repeating. Simple as that. And our rule to be a function was x values can't repeat. So if a vertical line hits more than once, then that tells you you have x values that are repeating, and your answer will simply be not a function. Alright, C and D. Those are for you. Are those functions? Yes or no? Use the vertical line test to tell me. Domain and range. Alright, let's go back again and remember. Domain is the set of all values of the independent variable, typically x. Range is the dependent variable, typically y. So, as I look at this picture, to find its domain, I'm looking for all the x values that are used. Okay, I zoomed in a bit so we can see the numbers here. So, domain means the x numbers. So, domain. So I'm looking at my graph here, and x goes left and right. X goes in this direction. So when I'm looking for domain, what I'm looking for is the furthest left point. I think the furthest left point is here, and that looks like it's x equals -3, to the furthest right point. So I follow my graph along. The furthest point on the right looks like it's right here. So x is any number in between -3 and 2. So the way we write that is we write -3 less than or equal to x less than or equal to 2. That would be our domain. Range, on the other hand, means the y values. So I'm looking for the lowest y value to the highest y value. Y's go in this direction, up and down. The lowest point on the graph appears to be right here, where y looks to be -5. On the other hand, the highest point on the graph is this one. And a real common mistake people will make is they'll use this point here. That point was very important for the domain, but not so important for the range. Range means go from the lowest spot on the graph to the highest spot on the graph. So our range, our lowest point was -5, and our highest point looks to be 4. So our range would be, ooh, you can't see what I'm writing here because I zoomed in so far. Domain is between -3 and 2, and range is between -5 and 4. And notice domain has the x values, range has the y values. Alright, let's look at B here. Same deal, we want to find the domain, and we want to find the range. I'll try writing a little closer to the graph this time so we can see what I'm talking about. So, domain means how far left does this graph go, and how far right does this graph go. Well, notice this time that on the end of this graph right here, there's a little arrow. What that means is that graph keeps going up and left forever. Forever and ever and ever. So how far left does it go? It keeps going forever. It goes all the way down to -infinity. It goes forever. At the same time, on this end, there's also an arrow, which means on this direction, the graph keeps going up and to the right forever. So how far right does it go? It goes forever and ever. It goes all the way to +infinity. So we can use any number. Eventually, this graph goes all the way to the left. Eventually, it goes all the way to the right. That means we can use any number in the whole wide world we want. And the way we write that is we say all real numbers. We can write that out in words as I did, or we can use symbols. A symbol for all real numbers is kind of a fancy R. I'm not a big fan of using fancy R here because I tend to use R for range and I don't want those to be confusing. Or the other symbol you will see, you could write X is any number between -infinity and +infinity. Typically we simply write the words all real numbers, but if you like symbols you could write either of those too. Alright, the range. The range, we look for the lowest y value on the whole graph. The lowest y value on the whole graph appears to be right here. And then we look for the highest y value, but we already kind of talked about this. The y values, because they have arrows on the graph, on the ends here, this graph keeps going up and up and up forever. So our lowest y value appears to be -4, but the graph goes up forever. So we typically write our range here as y is any number greater than or equal to -4. Okay, so that can happen. Sometimes your domain can be all real numbers. It's also possible that your range can be all real numbers. And it's possible that your domain and range can both be limited as so. It's possible that one can be limited and one isn't. And one might only be limited on one side. It has a low point and goes up high forever. Okay, you're going to repeat that same process with problem C. So you're going to find the domain and the range, and you might have guessed, you're also going to do problem D, find the domain and the range. Okay, so now we're moving into section 5.3. In section 5.2, we looked at graphs in terms of tables of values, and we also looked at graphs in terms of functions. Or, I'm sorry, we looked at functions in terms of graphs. Here in section 5.3, we're going to look at functions in terms of formulas. And we use a slightly different symbol than what we've used in the past. In the past, we've used the letter y. We might have written y equals 3x plus 1. Instead of using the symbol y, now we're going to use this symbol f parenthesis x. And all this symbol means your function name is f. And x is the independent variable. Now, this is a little bit poor notation, I think. These round parentheses, they typically look like multiply. Here, when we're using functions, round parentheses don't mean multiply. They simply mean this is your function, this is your independent variable. So, what this first symbol means, this symbol means our function is f, plug in 2 for your independent variable. In other words, instead of writing the letter x here in our formula, we're going to write the number 2. So this symbol, f parenthesis 2, means 3 times 2 plus 1. Where that x was, I plug in the number 2. I do the arithmetic, I get 7. Similarly, f at -4. That means don't write the letter x there anymore, write the number -4. Now, a strong suggestion I'm going to have. Whenever you plug in negative numbers, it's a really good idea to put them in parentheses like that. That will help you maintain the proper order of operations. Of course, I still got to add the 1 on the end. I multiply 3 times -4 is -12. -12 plus 1, -11. Alright, well, hopefully you've got the hang of this. F at 7, all that symbol means is don't write the letter x, write the number 7. Work out the arithmetic. 21. Alright, now this may look a little weird. F parenthesis a minus 4. Well, all that means is we go up to our formula here. We don't write the letter x, we write a minus 4. So I'm going to have a 3. I have to multiply that by a minus 4 and then add 1. That's all that means. Notice there's absolutely no multiplying. I'm not multiplying by a minus 4, I'm plugging in. I took a minus 4 and I plugged it in where the x is. Well, this one we might do a little simplifying. That's 3a minus 12 plus 1, 3a minus 11. This last one, this one's silly, but I like to point out that the symbol does have a meaning. What this symbol means is don't write the letter x, rather write the word cat. So what this symbol tells you to do, this is 3 times cat plus 1. I have no idea what that means. It has no meaning, actually. That's what it means. But it's a good example of what function notation means. Function notation means simply plug it in. Don't multiply by it. Don't do anything else with it. Just plug it in. Alright, problem 2. Same problem, slightly different function. Plug in your values and see what you get. Watch out for the negatives, because this does have a negative in it already. Alright, the last couple things we have. Let f of x be 3x plus 1. determine x such that f of x equals 7. Alright, you might remember in the previous problem we had f of x equals 3x plus 1. And I might have asked you to do something like f at 4. That symbol meant plug in the number 4 for x. And you work it out. Now what I'm telling you is you have to find x such that when you plug in the answer you get the number 7. Okay? In other words, all I did here is I told you the x number is 4, and you went ahead and you figured out the y number is 13. When I give you this symbol now says I'm telling you the y number is 7. You need to tell me what the x number is. A lot of fancy symbols for saying 3x plus 1 equals 7. Solve that equation. I subtract 1 from both sides. 3x is 6. Divide. X is 2. Alright. B. Another one for you. Alright, we're almost done. It says, consider the graph given below. Evaluate f at 1. Okay, again, what we need to know is we need to understand what this symbol means. This symbol, as written, means x is the number 1. What's the y number? So I go to the graph. X equals 1 is right here. I read the y number. Well, I got to make a little estimation here. I would say for this one, y is negative 1.5. B. That's for you. That one is saying x is the number 4. What's the y number? C and D. C is now saying y is the number 0. What's the x number? Alright, so I look at my graph. I go to where y is 0. That's right along here. Looks like it's right there. So it looks like x is 3. And as you guessed, part D is for you. Part D is saying the y number is 5. Y number is 5. That's up here. You tell me what the x number is. And again, you might have to estimate a little bit, make a guess. Alright, so 2 sections, but fairly short. However, a very important concept. Function notation will be pretty important for the rest of this course, and certainly very, very important for other math courses that you may take.